Are you able to see my screen? See, what I intend to cover today is memory layout of C program. In fact, I should have done it in the beginning, but since some clarity has to be there from your end to understand this particular topic in C program, so that is why I deferred this till today. So we all know that a C program has a structure like this. We have a header section, then where we have global declaration like this, where I have a global variable global, which is initialized to 0, and another global variable int, which is not initialized. Then you could have your hash defined constants or macros, whatever. So just let me put one or two here. And you have main and you have your own. Now, when you compile the program, okay, it is converted into machine code ultimately, and machine code, when it is put in the memory, the structure of that memory layout of C program would look like this. It's a huge block of memory. The top portion, which we call it as high memory, it means that memory address of this will be higher. For example, this could be 8,000 here, and down, as you go down, it will be 6,000 or whatever. Okay. I'm just giving one example. So high end of the memory, we have command line arguments. So as you all know, main function takes command line arguments. So we were putting command line arguments here, the argc, argv, and environment p. So all those, when you pass here, they come and sit here. So argc and argv will be in this part of the memory. Then I was talking about stack all the time. Probably you did not get what I was talking about. So stack is again the memory portion of the program where it is reserved for doing certain specific tasks. For example, all the local variables that you declare, for example, int x equal to pi or y, they go and sit in this part of the memory. So x equal to 5 would be here, and y equal to some garbage value because it is not initialized. So this is where the memory is allocated for the local variables. Okay. And there is one more memory which is going in the opposite direction of stack, that is called as heap. So heap is a special data structure which we'll learn in data structures. This is organization of memory, which is heap is used for allocating memory to objects which are dynamic in nature. For example, you want to create a linked list, and linked list, we know the size varies during runtime. So how do we allocate memory during runtime? So that memory comes from the portion which is designated as heap. So heap goes upwards and your stack grows downwards. Of course, there should be some boundary here that each of these heap and stack should respect. They should not cross over. If at all they hit the boundary, there will be an error and the program stops. Okay. Then the uninitialized variables, especially the one which are global variables. As you can see, there is one uninitialized variable that goes in uninitialized segment. And this is called as block started by symbol. BSS stands for block started by symbol. Now, this was a nomenclature used in assembly language, which has been continued here also. It has a special meaning because when I say block started by symbol, the all the variables which are in the global segment which are not initialized, they are allocated space here. So since count is an integer, 4 bytes are allocated. And then initialize variables. Again, global variables, sometimes you may want to initialize. So moment you initialize, they will not be in the BSS segment, they will be in the data segment, which is initialized variable. So your variable global will be initialized to whatever the initial value. It need not be always 0. But since I have written as 0, it is getting initialized to 0. Okay. And what you see later part be, below the data segment is all is your code or the program in the machine instruction form. So the code will go here. Okay. Along with the code, any constants that you have declared, they will all go here. So the text part of the memory layout contains your source code plus any constants that you define. So it is important to understand that when you compile your program, it will have so many different parts when it is laid out in memory. So what exactly is happening? Where are your command line arguments? Where are your local variables? Where are your function call return addresses? You should all know clearly. Similarly, when you allocate memory at runtime, where it is allocated? It is allocated in the heap. Then if you declare any global variables which are uninitialized, they go into BSS segment, and any global variable which is initialized, they get into the data segment. And the code and constants, they all occupy the lowest portion of your memory layout. Okay, so this picture helps you to understand what exactly is happening when you compile the code and try to run. Whole program will be residing in your random access memory or RAM, and it will be laid out like this. And the code segment is deliberately made read only. Okay, you can guess why. Because the instruction should not be modified by any other program at runtime, because you have written the logic should not change here. All right, so this text portion is read only. Rest of the memory is all read write, because we will be initializing the variables, we will be altering the values of the variables, we will be allocating memory at runtime. So they are all dynamic in nature, whereas the text part and the constants will all be read only.
Sir, what happens when memory is full?
Yeah, so there is a operating system which will be monitoring all this. If whenever the program doesn't find memory, there will be a signal which is generated, which is called as segmentation violation error. Okay, so there
Okay.
is a signal called as segv.
Okay.
This is raised, and the same thing is notified to the user who is running the program, or the operating system will take some action.
Okay, like user will come to know only after running the program that
Yeah, yeah,
this
because
option.
memory overflows happen when during runtime.
Oh, okay, okay.
Yeah, at compile time, the only the static part of it.
Hmm.
As you go on allocating memory, the memory may get full. For example, if I call main function recursively without putting
Hmm.
a terminating condition, the
Hmm.
stack starts growing like this, and when it hits the boundary, it will exit.
Okay.
That stack full error will come.
Mm-hmm.
Hmm?
Okay.
You can experiment that and see. Hmm?
Okay.
Similarly, dynamically you're allocating memory. There is a function called as malloc. You might have heard
Hmm.
of. This will allocate memory at runtime, and if you allocate far too much memory, which is beyond the limits of the heap, it will
Hmm.
again throw an error. Okay, so these are some of the things we should be aware of.
Okay. So just one more doubt. So
Yeah.
each program will have a certain memory allocated to
Y-
that program,
Yes, yes,
right? Okay. So
yeah,
and if it overflows, I mean, if it is more than, if we are allocating more than that, then we get this error.
yes, yes,
Thanks, sir.
yeah. See, the reason why I covered this is you should have clearer understanding of what all is happening behind the scene. When you move to development,
Hmm.
role, you should be aware of how the C program is laid out in memory, what is where, and what happens when you do something not acceptable. Okay, so
Hmm.
you should be able to figure out why that error is coming and what you should do to rectify that. Hmm? Yeah. So this was something little important, and that's why I wanted to cover it today. Hmm?
Sir, sorry, just
Yeah.
one more.
Yeah.
Suppose we have declared a variable, right?
Hmm.
And we allocate memory for it, a variable, an array, or anything.
Okay.
So, uh, do we need to, I mean, free that in the end of the program?
Yeah. Now, if it is static
How
memory
that
like
works?
array and all, uh, you need not pre. The system will do that. But if you use malloc,
Oh. Ah,
it is your responsibility to free it.
okay.
Yeah,
Okay.
because C program puts lot of responsibility on the programmer. It
Mm,
assumes that program is aware of all these things, and then it gives freedom also, and also puts a responsibility also.
okay.
So after allocating memory, for example, here I am allocating, memory for an integer variable
Mm,
and assigning it to a pointer. After the usage of all this, at the end you should say free f, free p. So the
okay.
memory allocated to pointer p in the heap here
Mm.
is deallocated.
Okay, so what if I call this function somewhere else in this program itself? So again, the allocation will happen once again from the start.
No, if you have a function,
Mm,
see this is
see,
the
this is a
hmm,
function in star p is some function.
yeah,
So my program is big and I am calling it multiple times.
yeah.
So whatever is, I mean, every time it allocates and then it frees the memory. Is that how it works?
For which variable?
Oh, this int star p is equal to this one, malloc.
Yeah, because every time it has to allocate, no, because you have freed it up.
Yeah, okay.
Hmm.
Mm-hmm.
Okay, and again you have a function here. If you declare a variable int x here, this x is
Mm,
a local variable, so that goes
mm,
and sits here as a
mm,
different copy, which is again containing some garbage here. So this x
oh,
is different, this x is different.
okay, okay, okay,
Okay.
sir.
But all of these local variables, whichever wherever they are, whether in main or in some user-defined function, they all get allocated in the stack area.
Okay.
Hmm?
Mm-hmm.
Okay.
Mm, okay.
Yeah. Yeah.
Thank you.
Okay. Good. Hmm? Now, as I promised you last time that we should cover some more functions which are recursive in nature. I mentioned about merge sort and quick sort. So let's see one of these in great detail, and we can see how program logic has to be written for implementing merge sort using recursion. Hmm. So let's first understand how merge sort works. So the basic principle of this is divide and conquer. That is, you are given a array of let us say 6 elements here, and if you want to sort this, I will divide this into half and then try to see if I can sort. If not, if it is problem is too big, again I divide and just like that until I cannot divide further. Hmm? So here if you observe this array which is given here with elements 7, 9, 3, 2, 11, 6 has 6 elements starting from index 0 to 5 n equal to 6. Now if I divide this list, so how do I divide? I take the uh, low index of the array and the high index of the array and divide by 2, just the way we did it in binary search. So the low value is 0, high value is 5 divided by 2. Now we get value 2.5. It is integer division, you get 2. So if you check the indices 0, 1, 2, the division happens here. Okay, so this is a lower list and this is upper list. Okay, now in the after division, the low end of the lower array remains low and the high end of the array will be set to mid. Okay, and upper list will get low end of the array as mid plus 1 and the high end of the upper array will remain high, which is y, and here it will be 3 and this will be 2. So the lower part of the array will be 0, 1, 2 and upper part of the array will be 3, 4, 5. This division is clear. Okay, now in the next part what happens is this array is taken and again the division is done. So the mid of this new array will be the low end of the array is 0, high end of the array is 2 divided by 2. you get it as 1. Okay. Now this list will be 7, 9 as the lower part. This is low and this will be high. And the upper part will be only 3, where it will be low will be this and high will also be this. Isn't it? Because if I take low equal to mid plus 1, which is 1 plus 1, 2, which will be exactly same as the high of the lower list, which is this. So in there are two lists now. This is your lower half, this is your upper half. Upper half contains only one element now, whereas lower half has two elements. So as long as there are more than one element, again you divide this. So that you will be left with one element here, one element here. Now you cannot further divide. Only now what you can do is you can merge these two. Merging is nothing but putting them in sorted order. So already 7 and 9 in proper order. So you keep them as 7 and 9 here. And the upper list contains only one element. You simply keep it as it is. So 3 here. So as you can see, the upper list is 7, 9 and sorry, lower list is 7, 9, upper list is only 3. Now you got to merge these two sublists. So when I merge these two sublists, I have to copy the lower of the two sublists. So lower of the two sublists is 3 here. Now upper half is exhausted. All that you have to do is copy the remaining elements here because they are already sorted. So 7, 9 is what you get. So you get the lower list sorted like this. Now come to this upper half here. Here when you divide, what happens? So mid of this upper list will be low plus high by 2. Low value is 3, high value is 5 divided by 2. That is 8 by 2 is 4. Okay, so where will that be? 4 is here. It means the list gets divided like this. So the lower half will be 2 and 11 and upper half will be only 6. Now if you further divide this, it will be 2 here, 11 here. Again when you merge you get 2, 11 as they are, and the upper half contains only one element. It will descend like this. Now when you merge these two sublists, if you compare 2 and 6, the lower of the two is 2. Then compare 11 and 6, 6 is lowest and 11 only the remaining element has to be copied like this. Now you have upper list also sorted and lower list also sorted. You got to merge these two. So when you merge these two, again you compare the first element of upper half with the first element of the lower half, copy the lowest among the two, that is 2. Whichever element you copy, you move the index of that to next element. Again compare 3 with 6. You will see that 3 is smaller. You copy from here. You move this index now. Now 7 and 6 are compared. 6 is smaller of the two. That is copied and this will move here. 7 and 11 are compared. 7 is the smaller. You copy here. This will move. 9 and 11 are compared. So 9 will come here. And only remaining element is 11. That is copied at the end. So you get the sorted list like this. Okay. Is the process is clear to you how divide and conquer is working or any doubts?
So can you please explain one more time, like how you compare lower with high?
Lower?
how you compare that to both
Sublist.
sorted
Okay,
sublists?
okay, okay, okay. Now you have two sorted sublists here, isn't it? You have two sorted sublists. This is one sorted sublist and this is another. Hmm?
Okay.
Now array is same A. Okay. You have to take an index I here, which is initially low, that is 0 here, and here you take an index j, whatever is the index now, 0, 1, 2, 3. This j will be 3. Okay.
Okay.
Now what you have to do is you check if a of I less than a of j, then now while merging you require one more array because you cannot do it in place. So this is a new array B, and to keep track of elements in B, you have to take one more variable K. So when you compare these two, you observe that AI is less than AJ, then you should copy in B using the index K A of I here and increment the index I like this. Okay, in the else part, you will copy the J element because,
J is greater.
yeah, because AJ is greater than AI. So this is the only logic that is required to copy the smaller of the two sublists.
Okay.
Okay, how long should I continue? As long as one of the list is exhausted. Once that happens, you copy the elements in the remaining list, if at all any, and then copy these elements of B back to A because we want sorted list in A. So every element of B should be copied into A. How to do that we shall see in the program.
Okay.
Okay. So
Thanks.
the thing is you have to design a program which will recursively divide the list into smaller and smaller instances until it cannot divide further. So how does merge sort look like? So merge sort you can like write like this: merge sort. You are taking an array A with the low index of the array and high index of the array. Okay. So since this is an array, it should be like this. I'm not indicating the data types here just for clarity. We can do that when we write the program. So this is the main program which will run recursively. So what you have to do is you have to take one local variable mid and find the mid element of this low plus high by 2. Okay. And recursively call the same merge sort with array A. When we want to go on the left half, the low part will remain low and the high part will become mid. Okay, so this will take care of the left half. Once you come out of left half, you have to go on the right half. So again merge sort A comma. This time the low part will be mid plus 1 and high will remain high. Okay, so after you have gone to the left and gone to the right and both the parts are sorted, you have to merge. So there will be a merge step. For merging, you require the same array A, the low part of the array, the mid part of the array, and also the high part of the array. Okay, so this is the structure of the main merge sort. Now, for every recursive function, there should be a terminating condition. So, how long should I continue? So, there should be a if statement. Okay, so here, as long as there are more than one element, that is low less than, is it equal to or high? I just have to check this. We'll see that. So as long as there are enough elements, you should keep doing this. So this recursive function will take care of dividing the list and see that the elements are arranged and the merging step happens. So this merging part is important. We have to write that ourselves. So again, you will write a function merge, taking an array A, then low, mid, and high. Now, what do we do here? Here we need to compare the elements of the lower half with that of the upper half and copy as required. So here you will declare an array B of some size, let us say some 20 or whatever, depending on what is the maximum number of elements you are allowing to be included. So you require a low index I, which is set to low, and you require index j, which is set to mid plus 1, and you require an index k, which is set to again low, not 0, because every time you will be sending different sublists, so k value has to be appropriately set like that. Now what you should do is you have to while I less than or equal to mid and j less than or equal to high, until one of the list is exhausted, you should continue like this, isn't it? Because you never know which one will exhaust first. So that is why there is a AND condition. Now within this, what I have to do is I have to check if A of I less than A of j, then copy into B AI and increment index I at the same time. Else copy into B A of j. Hmm? Okay, so when you come out of this while loop, what would have happened? You would have copied the elements in sorted order, and one of the list would have exhausted. So which list is exhausted, we don't know. I might have crossed mid or j might have crossed high. So what I can do is, instead of again checking that condition, I can again put a while condition here. While I less than equal to mid, you simply copy into A the remaining elements. Sorry, copy the remaining elements in B from the lower half. Okay. So if I has crossed mid, then this will not execute at all. Similarly, if the upper half is not exhausted, which you can know by checking this condition, if j less than equal to high, then still there are some elements left in upper half, so that you can copy into B using this j plus plus. Okay. Now once you are done with this, you have to copy all the elements of A into B into A. So you can set up a for loop for I equal to low, I less than equal to high, I plus plus, A of I equal to B of I. See, I'm using index I, so don't get confused why I'm not using K here. The K's role was over at this point in time. Simply you have to copy all the elements in B into A. I'm not doing A plus plus also or BI plus plus also, because that I is getting incremented here. So this loop will copy all elements of B into A. Hmm? And you just return from this function. So when you return here, this merged list would have come, and again you will continue like that. So this is the procedure to implement merge sort, which is slightly more complex, as you can see. The main merge sort function will only do divide the list into sub halves. The divided lists are sorted and merged in the merge function, and if you do it repeatedly, you will get all the elements sorted. Okay, any doubts here? Is it good to go with the program now? Let's see the
Yes.
implementation. Okay,
Yes, sir.
yeah, we'll see the
Yes.
implementation of this, so that will clarify everything. We need to have the array first. So int a equal to certain set of values. You can say 7, 5. How many elements we have? 1, 2, 3, 4, 5, 6, 7. So int n is equal to 7 elements are there, right? Now I need to call merge sort function here, which will take the array A, then the low index of the array is 0 and high index of the array is n minus 1. This is how I would call. And once this function comes back, I will have sorted list. So I would use a loop to display them. I need to declare a variable I here and just print percentage d, bit of space and a of I. And this merge sort we can. So this is the main function which will call merge sort. So the merge sort function we have to write below this void merge sort. So just observe how the function definition has to be done. The first argument is an array. I indicate that to the square bracket. The other two variables are low and high. Initially they are 0 and n minus 1. Hmm. We require a local variable mid here, and we need to check if low less than high. I need to repeatedly call the recursive function. So before calling recursively, I should calculate the midpoint by adding low and high and dividing it by 2. And I'll call merge sort on the lower half, okay, then followed by merge sort on the upper half, and after both of them come back, after the further division is not possible, then you have to merge the two sublists. Here we require again the array, the low part of the array, the midpoint and also the high point. All three required. So as you can see, the two merge sorts and the merge all are in the if block. So once you come out of the if block, it means you are done with the sorting and you get the result. So I need to implement the merge function. This is again an array. Here you have three arguments. Yeah. Now we require a lot of local variables. I, j equal to mid. Then you require k equal to low. Okay. So these are the three variables I require, and I require one local array also b. We can set it to some, let's say, 10 elements. So I have large enough to hold those 7 elements. Okay. Now here I need to check while I less than equal to mid and j less than equal to high, I should check if the lower half's first element is smaller than the upper half's first element. If that is the case, copy that into B. Else, copy the upper element into B. Okay. So you just keep doing this until one of the list is exhausted. So when you come out of the loop, you set up a while loop, check whether lower half is still unexhausted. You copy the remaining elements into B. And similarly, if j is less than equal to high, copy that into b from the upper half, that is aj plus plus. Okay, and now you set up a loop for I is equal to low, I less than equal to high, I plus plus, a of I is equal to b of I. So copy everything from b to a. So b has a temporary role of holding the merged elements, and then it will return all that into a. Okay, so what remains is we have to define the function prototypes here. Void merge sort, it accepts an integer array, then two integer arguments like that, and your merge function returns nothing. It accepts an array and three arguments here. Okay, so have I missed anything? Seems to be okay. We will see whether it sorts the elements and gets us the list. Only concern is whether it is low, less than high. Yeah, so it is not sorting. So there is some problem. I think so it is low, less than, equal to high. Mhm. It should be low, less than high only, because as long as there are more than one element, you should divide that. Is anything wrong? 5, 7, 4, 1, 2, 3, 7 elements. 1, 2, 3, 4, 5, 6, 7. That's 7%. This is correct. Equal to low, j equal to mid. Oh, j should be equal to mid plus 1. Sorry, because it should point to the upper half elements. Let's see. Yeah, now you see that is sorted. 1, 2, 3, 4, 5, 7, 9. Okay, so only mistake was j I was putting to mid, which was the upper half of the upper end of the lower half. So it should point to the lower end of the upper half, isn't it? Because our array was something like this. You had array A, low end here, the mid will be like this, and mid plus 1, it will extend up to high. Okay, and your I should point to this low end, and j should point to this high end of the, j should point to mid plus 1, which is upper half of the array. Now why this confusion happens is that everything is happening in the same array. I am not dividing the array and putting them to two sub arrays or two different arrays. In the same array, I should identify which is the lower half, which is the upper half. So the lower half extends from low to mid. That is why I should point to low, and the upper half will start from mid plus 1. So that is why j should start from mid plus 1, and it can go up to high. That is what I am doing here. J less than or equal to high. It means j will advance one position and try to reach high, and I will advance one step and try to meet the midpoint of the array. That is the upper half of the upper end of the lower half. Okay, so I can go only up to midpoint. And when I do all this, we get the sorted list. So it's slightly heavy for all of you. I know, because a lot of code has to be written. This part appears simple because you only have to divide the list and merge it. Okay, but implementing this merge function is pretty involved, and you should try to understand it step by step. Hmm? So would you like to try this out?
Yeah, sir.
I think so. You must try this out. Just go ahead and see if you can implement and experience for yourself whether merge sort works for you. Hmm? Yeah.
Yes, sir.
Okay. Now
Yes, sir.
let us see another divide and conquer approach to sort the elements. It's called quick sort. So this method was invented by one computer scientist by name Car Hoare, 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 like that. So what he did is he again opposed divide and conquer, but he avoided the use of an extra array. So the sorting was in place, and also the merging step is not required here. So how we managed to do this and what approach he took? Let us see with an example. So let us say 7, 5, 3, 9, 2, 4, 1, like this. Okay. So this is the low end of the array, and this is the high end of the array. 0, 1, 2, 3, 4, 5, 6. So 6. So n is equal to, there are 7 elements. Now what he did is instead of dividing and merging the lists, he tried to do that without merging the lists. So how he achieved that? So he brought in one concept called as pivot. So you call it as pivot or pivot, whatever. So what he did is you identify one of the elements as pivot. Okay, so for simplicity, you can assume the first element itself as pivot, designated as pivot. Hmm? You are free to choose any element as pivot, it works, but for simple implementation, let's take this as pivot. Now you have to take one index I which starts uh, at for as the second element here, and you take an index j which is at the last position. So j will be high and I will be low plus 1. So I will be low plus 1. Now what you have to do is you have to partition this list. You have to move 7 in the list such that after you place 7, you don't know where exactly to put 7. Let us say you put somewhere here. After putting, all elements onto the left should be smaller than 7, and all elements on the right should be larger than 7. Okay, so how do I achieve this? So for that, he devised one procedure. The procedure is you should take index I and go on comparing element at index I with the pivot until you find an element which is bigger than pivot. So as you can see, if I compare with 5, 5 is smaller than 7, so you advance I by 1, it goes to 3. Again compare, 3 is smaller than 7, again you proceed. Here you will see that element at index I is larger than 7, so you stop. Okay. So from when you traverse from left to right with index I, you always look for an element which is bigger than the pivot. So once you hit the bigger element than the pivot, you stop. You do exactly the opposite with J. You traverse from right to left until you find an element which is smaller than pivot. So as you can see, element at index 6 already smaller than 7, right? So you don't advance J, it will stop here only. Okay. Suppose if it were 11, you would have moved it here because 11 is greater than 7, you would have moved J here. But now in our case, this is 1, so you stop here. Now at this stage, what do I do? I compare I with J. whether I is less than j. I check whether I is less than j. If that is the case, then exchange element at index I with that at index j. It means I have to move this 9 here at position last and 1 back here. Hmm? So simply exchange element at index I and that with element at index j. Okay. Now when I do that, this 9 will move at position 1 and 1 will come here. You got this step? Okay. So after doing this step, again you have to proceed the same way. Now you see that element at index I is smaller than the pivot, you proceed further. So you move I to the next element. You will again see that element 2 is smaller than the pivot, again you move I to the next position. Again you will see that 4 is less than 7, you proceed. So I will coincide with J. Okay. There are,
Sir, Arpita is waiting, it seems. Can you please let her in?
okay, sir. Just 1 minute, I'll admit her. That email invite is not working, huh?
I'm not sure from
Yeah,
how.
because if you click on,
Okay, I'll ping her that. I think she has that link.
1 minute, I'll admit her if she is there. No, she is not sent the request. Ask her to send,
Okay, okay.
or if she has email invite, ask her to click it automatically admit. Uh, Ask her to try through email invite, and if she tries to,
Yeah, I told her.
yeah, okay, okay. So we're here. Yeah. Now you stop at index at the last point in the array, and again uh, do that for index j now. So j will start moving. You should look for an element which is smaller than pivot. So j will move here. You'll see that 4 is less than 7, so it will stop. Okay. Now check whether I less than j. I is greater than j in this case. All of you agree? Because I has moved till the last point. That is, I has become 6 and j is 5. So if I is greater than j, then you exchange element at position j with that at the pivot. So pivot element has to be exchanged with the element at index j. So when I do that, let us see what happens. In this place, you will get 7 and 4 will move to the first place. Now see what has happened. This is the position where pivot is positioned. Okay, whatever pivot we choose, it has come here. Now if you observe, all elements on the left of pivot, are they smaller than 7? Isn't it?
Yeah.
Yeah, and all elements which are on the right of 7, are they not greater? Because even though there is only one element, it is greater, right? So we have positioned J such that it is partitioned and 7 is the right place in the sorted array. So 7 is already sorted. You only have to sort the lower half and upper half. Now in the upper half there is only one element, so you don't have to sort, that is also sorted. What is left is only this part now. The lower half has to be sorted. Is anyone
Yeah.
trying to? Okay, so now what will I do? Lower half is not sorted, right? After this first iteration, I should again take up similar procedure. Again identify the first element as pivot. Now the pivot has become 4, right? So pivot value is 4. Again, I'll start I at this point and j at this point now, because we are done with the upper half. Hmm? So j will always be at the end of the list, whether lower list or upper list. Now lower list is bigger, j will start here. So again, how do I proceed? I look for an element which is bigger than pivot. So you will hit the first element is itself as bigger. You stop here. I stops here. And j has to look for an element which is smaller than the pivot, right? So j is pointing to number 2, which is smaller than the pivot. It will stop there only. It will not proceed here. Okay. So now you check I less than j, that is a of I less than j. Okay, sorry, not a, j, j. You have to check the indices. You check whether I less than j, whether I has not crossed j. If that is the case, you exchange element at position I with that at position j. So what happens? The 2 comes here and 5 moves here. Now the journey continues. So I will move here. You look for an element which is smaller than the pivot. Uh, it is look for an element which is bigger than the pivot. It is smaller now. I will again move, again smaller. I will coincide with j, and j has to move to the left now. J will come here. You will see that element at index j is 1, which is smaller than the pivot. It will stop. Now we have again uh, encountered the same condition that I has crossed j. Whenever I crosses j, you just have to exchange the pivot with the element at index j. Index j is here, right? So your I has moved to the last position. I remove this I. I is here and j is here. So I has crossed j. Now exchange these two. So what will happen now? 4 will come here and 1 will go here. Now you have partitioned the list around this pivot, new pivot now. As you can see, all elements onto the left of 4 are smaller and all elements onto the right of 4 are bigger. Okay. 5, only one element, it is already sorted. 4 is sorted. On the lower half, again, you'll see 1, 2, 3 are already in the order. So the whole list is sorted. So as you can see how fast it could sort. Okay. So this is one of the best algorithms, but it works well only for average case, that is elements are randomly placed. If they are already sorted, it takes longer time. That is one worst part of it. For sorted list, it doesn't work well. So that is why you should have a randomized inputs where the elements are randomly scattered, so that the algorithm work best when that is the case. Okay. So the approach here is you have to partition the list with a pivot element, hmm, such that all elements on the left of pivot are smaller and those on the right are greater or larger. So this is the strategy behind quicksort. Now, how does quicksort algorithm look like? Okay, so the main quicksort resembles that of your merge sort. So you take an array, then you have a low index and a high index. So here you have to have a terminating condition as long as low is less than high. That means at least two elements are there. You have to perform these steps. So you don't find the midpoint here. So what you do is you call a function called as partition that will return the index j where you place the pivot in the above example. It takes the array A, then your low point and the high point. So this function partition we have to write. How to do that we shall see subsequently. So once you get the index j, the position of the partition, you know where is the midpoint or the point around which the sorting has to do. Again you call quick sort. If you want to go to the lower half, then keep the low as it is and high will be j. And if you want to go on the upper half, quick sort a j plus 1 to I. There is no merge step here. So this is the same type of algorithm. Instead of finding midpoint, I am finding the index of the partition. And I am calling quick sort on the left half and again calling quick sort on the right half. So let us see how this partition algorithm has to be written, or the partition function has to be written. Here I will write partition. We have array A, int low and int high. Okay. Now as you can observe that we require a couple of variables here. We require a pivot, then you require index I and index j. So what you have to do is you have to take first element as pivot, A of low, and I will be set to low plus 1 and j will be set to high, isn't it? Because I have to traverse from left to right. From left to right I go with index I and from right to left I go with index j. Okay, so I have a condition here while A of I less than pivot, you have to simply advance the index by 1. So go on comparing until you hit an element which is bigger than the pivot. Okay, and you set up one more loop while A of j greater than the pivot. Okay, and when you come out of these loops, you check if I less than j. If that is the case, you call function exchange with AI and AJ. So AI and AJ have to be exchanged. Hmm? Yeah. Now this has to be uh, continued as long as I is less than j. So here there will be condition if I less than, sorry, there should be a while here. While I less than j, do this. Moment I crosses j, you come out of the loop. When you come out of the loop, you have to exchange the pivot element which is at index low with that at j. So pivot element is here and element at index j is here. And this function has to return j. I made one small mistake because this j is required in the main quicksort. So the return type of this partition will not be wide, it will be int. So this partition will find out an element which is larger than the pivot and stop there, and this second loop will find an element smaller than the pivot and stop if it cannot find one, and then exchange if I less than j, and when you come out of the this while loop, you exchange a low with aj, hmm, and return this j. So once I get this j, which is the position of the pivot, I again call quicksort on the lower half here, and when I am done with that, I find quicksort on the upper half. Hmm? Yeah. So just try this out yourself. We'll see next time if it doesn't work for you. But the whole logic here is about partitioning and then sorting without using another array like the way we did in merge sort. Any doubts here? Hello? Or it is too confusing?
So we will try, sir.
Yeah, you try because I want you to try. There will be small issues somewhere. You try to debug, and if you can get it working, then great. I believe that you have paid enough attention to understand the method and you are able to write the program for it. All right? Okay. Uh, Faisal, what program you wanted me to demo?
Like a function returning function pointer.
Okay, okay, we'll do that. Those others, if you wish to leave, you can leave the session.
Uh,
Yeah,
no, sir, we have to do one more program, right?
which one?
Function returning pointers.
Yeah,
You
yeah.
said you will do it.
Like few more
That
examples.
is the one. Yeah, function returning
Oh, okay,
pointers.
okay, okay.
As like passing arguments, pointers as arguments and returning
Yeah,
pointer.
yeah. So if you're all interested, we'll do that. Do that. Yeah. I'll directly go to the demo here. I can start a new.
Sir, before that, can you just summarize, sir? I joined just 5 minutes back. What we went on today, right? Maybe if you can summarize that,
Ah,
that would help. I can watch the recording later.
oh, okay, okay. So what we did today is we looked at the memory layout of a C program. That is when the program is compiled and loaded in the memory by the GCC loader. There is a part of compiler called as loader, which ultimately takes your entire machine code and loads it into the memory. At that time, it lays it out in the diagram that I've shown you in the presentation, uh, where the highest part it will put all the command line arguments. If you remember, we discussed command line arguments, right? argc and argv. So
Mm-hmm.
anything that you type at the command prompt, they will go at the high point of the memory. Thereafter, you have a stack part where all local variables will be stored and the function return address of the functions will be stored. All right. And uh, the next part of the memory is heap, which is mainly used when you are dynamically allocating memory using malloc function, malloc or calloc. So there are two memory allocation functions, malloc and calloc. Malloc will allocate memory without initializing the memory content, whereas calloc will clear the memory content with zero values when it allocates. So that's the only difference. And
Okay.
we have uninitialized segment, which is called as BSS, block started by symbol, where all the global variables are stored, which are uninitialized. Okay. And the data segment contains again the global variables, which are all initialized. Now,
Okay.
who will initialize the variables which are there in the BSS? Okay. So the operating system has a function called as exec, which will create a new process and will execute this program. Before executing this program, it will put the uninitialized variables with initial value. Actually, it will put zero. So even if you declare a global variable, it will not contain garbage. It will print zero. You can check that. Since
Okay.
you are not initializing, doesn't mean it will contain garbage. It will contain zero value because the exec function of the operating system will initialize. Okay, and
Okay.
the text part contains all your code. this code is of main function also, or any function that you have written yourself. Now we wrote merge, sort, and merge. All those will go into the text part of the code. Okay,
Okay.
so this is the memory layout of C program. And we looked at divide and conquer approach, where we looked at two important algorithms, merge sort and quick sort. The merge sort will find the midpoint by using formula low plus high by 2, and
Hmm.
around this midpoint it will partition the lower half and upper half. Lower half has to be again divided if it is large enough. So we'll check whether there are more than one element, that is at least two elements are there, you will further divide. So when you cannot divide further, we go with the merge step. So the two sorted sublists are merged using the merge function. Okay.
Okay.
After
Okay.
merging, this again continues for the lower half as well as upper half, and at the end of the algorithm, you'll get the sorted list. Only disadvantage of merge sort is you have to use extra memory. Okay,
Okay.
one extra array is required. This is okay when you have 10 elements, 20 elements. Imagine you are sorting 1000 elements. So another 1000 bytes are required.
Hmm.
Okay, so that is not the case with quick sort, which will do sorting in place. In the same array, it will do that, but you have to write a partition function wherein you use an important concept called as pivot, around which the partitioning is done. Okay,
Okay.
yeah,
Okay, sir. I'll look at the video. Thanks. Thanks for the
okay,
brief.
okay, okay. Hmm? Yeah, all right. So let me show you some functions you want to call using pointers, and function should be returning pointer. So, okay. And how do I write signature of this function now? Oh, it worked. Uh, so that, uh, hmm. So the mistake was get me is a function which is not taking any argument. So I was not indicating that here. I was writing like this. So that is for pointer declaration.
Hmm.
Hmm. So I should write this and then put a bracket here, and then so get me is a function which doesn't take any arguments, but it returns a pointer to a function which returns integer value and take two integer arguments. Now it is correct. And then here star fp and this. Okay. So now what you wanted is what if this takes an argument here, right? Or pointer to a function. Faisal.
Yeah.
Okay. So let us say what you want to do here. Let us say we have void show printf some hello here, and you want to pass a function pointer which doesn't return anything and doesn't take anything as argument. This is what we wanted.
Mm-hmm.
Hmm? So accordingly, here also it should change now. Void
Why?
star fp, then doesn't take anything. And here I should
Sure.
pass show, right?
Sure. Sure.
I should pass show,
Mm-hmm.
and here I can call show before I can say fp here.
Yes.
Mhm.
Yeah.
So that show is called before add is written.
Right.
Is that what you wanted?
Mm-hmm.
Okay, let's see whether it works. Show undeclared. Yeah, that's correct. You have to give the prototype of show. Yeah,
Good.
got it. See this bracket here because this is for the whole get me function. Get me starts here, no? It
Mm-hmm.
should extend till here.
Okay.
And this closing bracket here corresponds to this opening bracket here. So now you see that when I'm passing show, that show is calling hello, and after that it is returning FP1. FP1 when you pass 5 7, it is printing 12.
Uh, Sir, give some exercise on this, sir, function
Yeah,
key.
yeah, I'll do. But if you wish, you can try this out now on that system if you have time. Or that is why C becomes quickly becomes an ugly code for many people to understand what it is doing. So many don't adventure into this, especially using pointers and function pointers. Just give a try and see that it works.
Yeah, thank you.
Okay. So you noted this. Shall we close for today?
Huh,
Okay. Okay.
thank you.
All right. All right. Thank you.